Good morning, good afternoon. Make sure you can hear me without me covering up the microphone. I don't know where the microphone is. So let's get started. We're going to do lesson 16. As I mentioned the other day, we're going to skip lesson 15. Not that it's not important, but we've got to pick and choose our battles right now so that we can get through necessary material before the end of the year. And by skipping 15, we're losing a little bit of practice on solving equations, but on the same time, we're going to be practicing solving equations. So if you haven't gotten it out already, get it out now. Let's look at 16.1. Let's write inequalities. We're going to write them and solve them. 16.1 says for each inequality, find the value or values of x that make it true. And if you remember what we've practiced the last day or two is when you have an inequality, just pretend it's an equal sign and then solve it. And then go back and put in the inequality. I mean, there's one little tiny caveat that I mentioned that when you divide or multiply by negatives, you have to switch the inequality symbol from greater than to less than. But we'll get to that when we encounter that a few times. But this first one says 8x plus 21 is less than or equal to 56. So I'm going to write 8x plus 21 and just say it's equal to 56. So what would step one be? Hopefully we start to recognize I got to subtract. And the way I do it, that equal sign, remember, is that balanced hanger. It's right where it balances. You'll notice I always take off 21 from each side. It helps me organize my thoughts, clear my thinking, so that I can stay on track. If I just subtract 21, sometimes I'll forget that I already messed with that. But what essentially that means is I took 21 off from each side of the hanger. So guess what? It's not even on this side anymore. And 56 take away 21 is going to be 35. And now I have 8x equals 35. So if 8x is equals 35, if there's x plus 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 x, if all 8 of them have to share 35, well then one of them, if I split 8x's 8 ways, split 35 8 ways, now I have x equals, I could just leave it like that, 35 eighths. 8 goes into 35. I could leave it that way, or I could just say 8 goes into 35 4 times, because that's 32 with a remainder of 3/8. Both answers are just fine. But I'm not done, because I said pretend it's x equals, but technically x is less than or equal to 35 eighths, or 4 3/8. If I plugged 4 3/8 in there, 8 times 4 3/8 plus the 21, anything less than that, what if I plugged in 3? 3 is less than 4 3/8. 8 times 3 is 24. 24 plus 21 is 45. Guess what? That's less than 56. So that works. Anything less than that, and we get our answer. Now, I'm going to erase this because I think I'm going to need some more space here. This next one I'm going to rewrite up here. 56 is less than 7 times 7 minus 7. Oops, 7 minus x. Lots of ways to solve this. I could distribute that 7. If I have 7 minus x, if I have 7 of those, it means I have 7 7s and 7 negative x's. That means I have 49 and negative. That's fine too. But if I have 7 of these equal to 56, I notice that the 7 and the 56 work very nicely together. If I divide each side by 7, if 7 of those equals 56, then one of those equals 56 divided by 7. And that equals 8. Notice I just divided by a positive number, so my symbol still stays the same. This time I'm not, and I could very easily just rewrite with an equal sign and then just solve it, and then at the end write back my inequality. Or I can just leave my inequality, as long as we don't write sloppy inequalities like me, and sometimes my greater than and less than's look like 7s or something like that. But next step is I have 7 minus x equals 8. I need to get rid of 7 from each side. 7, take away 7, and those cancel. 8 minus 7 is 1. And now I have a minus x left over on this side. Notice that minus x is still on that side. So if a negative x is greater than 1, this is the tricky part. You can't quite tell, but a negative x is kind of like saying I have a negative 1x. And in order to solve that, I'd kind of have to divide each side by a negative 1. And since I'm dividing each side by a negative, I need to switch the symbol around. But I'm going to go and erase that, because quite the easiest way, if a negative x equals 1, then a positive x is equal to a negative 1, except I need to switch this symbol around. It's a weird rule, and it's something you were supposed to explore in yesterday's lesson, but I skipped that lesson, or skipped 15 and jumped to 16 just because I already mentioned we've got to progress. So since I divided each side by a negative, not adding or subtracting. If I subtract or add, that doesn't matter. Adding and subtracting does not mean that the symbol changes, but it technically means I need to switch the symbol, and now that means x has to be less than a negative 1. A negative 2, negative 3, negative 4 cannot be bigger than a negative 1. 0, 1. If we plug in 0 in the equation, 7 minus 0 is 7. 7 times 7 is 49. 49 is not greater than 56. Notice that doesn't work if we don't switch their symbol around. So I hope our brains are warm. That's quite a warm-up. A lot going on there. But worthwhile task, to say the least. The next one says, choose the inequality that best matches each given situation and explain your reasoning. I'm going to be just speaking out loud. You can write down what I say or write down your own thoughts if you like to say it in a different way. But we don't even have to solve anything here. Eventually, we're going to have to choose one of these to solve, but we don't have to do that yet. So number 1 says the garden club is planting fruit trees in their school's garden. There's one large tree that needs 5 pounds of fertilizer. The rest are newly planted trees that need a half a pound of fertilizer each. So the tricky part about these next 4 problems are that they're throwing out a number that we don't even know where they're getting that number from. But there's still going to be several numbers that we do know. And in just a second, we're going to have to write a question that uses the random number they threw out there. And it's all doable once we select the right inequality. So if we have to, we read it again. Garden club's planting fruit trees. There's one large tree that needs 5 pounds of fertilizer. The rest are newly planted trees that need a half a pound of fertilizer. So what equation does that look like? Does that look like, is something 25 times something? I don't really see that anywhere. I don't see 25 in this problem being multiplied by anything. A half times something, a half times however many plants there are, that makes sense. Plus 5 pounds of fertilizer for that one tree. If it's one tree, I can just say plus 5. So that one seems correct to me. C says, I don't Again, I don't see this plus 25 yet. I see this half x. Less than 5, I don't see that. 5 times something plus a half. It's not really a half, but it's a half times however many trees. So, by process of elimination, and that must be the correct answer. The issue is what's that 25 mean? We'll get to that. We're going to have to interpret that. But for now, that's all we had to do is just select which one is the best. Number 2, the chemistry club is experimenting with different mixtures of water with a certain chemical, sodium polyacrylate. I think I said that right. To make fake snow. I wonder if that's how they do it on, no. I wonder if that's how they do that on certain ski mountains. To make each mixture, the students start with some amount of water and then add 1/7 of that amount of the chemical, and then 9 more grams of the chemical. The chemical's expensive, so there can't be more than a certain number of grams of the chemical in any one mixture. So I could see that being a less than or equal to problem. But nevertheless, let's read that. To make each mixture, the student starts with some amount of water and then add 1/7 of that amount. So I see 1/7 of that amount. We don't know what that amount is, but when I see 1/7 of, that means 1/7 times that amount. Don't know what it is, question mark or x. So probably looking for a 1/7 x type problem. It says, and then 9 more grams. So I'm going to add 9 to that. And looking at this, it looks like the very first problem, I see a 1/7 of that. Number 2 says 9 times something. I think the 9 grams is just a straight up 9. There's no 9 times that. Letter C, 26.25. Don't know where they're getting that from. Letter D, plus 26.25. Yeah, I think it's got to be A. So let's look at number 3. The hiking club is on a hike down a cliff. They begin at an elevation of 12 feet and descend at the rate of 3 feet per minute. They begin at 12 feet and descend. That means you're going down at a rate of 3 feet per minute. That means 3 feet every minute. That means 3 times however many minutes. In this case, you can use M. They used X. So I do see a 12 minus 3X right there. I see a 12X. The first one doesn't quite make sense because I don't see the 37 times something. B could be, but I don't see the minus 37 anywhere. And it says they're starting at 12 and then going down, so we have to start. So, and then the last one, D, doesn't really make sense because that 12, it's not 12 times something. So I'm pretty sure we got C there. If I'm going too fast, just pause, look at that, and see how that makes more sense to you. And then finally, the science club is researching boiling points. They learned that at high altitudes, water boils at lower temperatures. At sea level, water boils at 212 degrees Fahrenheit. With each increase of 500 feet in elevation, the boiling point of water is lowered by about 1,000 feet Fahrenheit. And this is totally true. Maybe you know this or not. When I lived in Gallup, New Mexico, the altitude there was like 5,000 feet. And the water, I had this electric tea kettle, I plugged it in, and it always boiled right at 200 degrees or somewhere right around there. And it was weird. Then moving here, all of a sudden, water didn't boil until it got to 210, 212 degrees, just kind of like it is here. We're closer to elevation, much closer to sea elevation. Although I never remember what we actually are. If I have time, I'll Google it. So this one is pretty crazy. The water boils at 212. With each increase in elevation, the boiling point of water is lowered. So if we start at elevation, we start at 212 degrees. Every time we go up, the boiling point is lowered. So when I look at all these, I'm trying to go, does A make sense? Maybe. B, everything is 1/500, so something's got to be 1/500. I don't have to mess with that. So 1/500 must mean something. E must stand for something. My guess is it's the elevation. And they're giving me the numbers here, 500, 212. So far, that's always been on the left side of the equation. In this case, it's going to be 1/500. So right now, A has both of them on the left side of the inequality, of the less than sign. And A is kind of the only one that does. But A, believe it or not, is correct. Because if I go up 500 feet, I lose a degree. Well, then how much do I lose if I go up 1 foot? Well, technically, I lose 1/500th of a degree. If I lose a degree for every 500 feet, well, then 1 foot, I'd lose 1/500th of a degree. 2 feet, I'd lose 2/500th of a degree. So every foot is 1/500th of a degree. And that's going to be less than 195. So, correct answer for 4 is A. A would be the right answer. Now, the good stuff. 16.3 says your teacher will assign your group. You're going to try this on your own right now, and then if you have time, you can compare this with somebody else who chose the same one. But you'll have to listen to the sub on how he wants that to unfold. He might just say, you know what, nope, just stay put and don't compare. It all kind of depends on how the things rock and roll. So 16.3 says your teacher's going to assign you. I'm going to let you pick one. And it says create a visual display about your situation. In your display, explain what the variable means. That means, what does X mean or E mean, and each part of the inequality. Explain what the variable and each part represents. I'm going to do one for you so you know what that means. Part 2 is, second dot says, write a question that can be answered by the solution. 3, show how you solved it, and then explain what your solution means. So I'm going to do this last one, and technically you will do it on a blank piece of paper, but I'll kind of leave it. I'll try to squeeze it on there so it's maybe easier for you. So first off, I've got explain what the variable and each part of the inequality represents. So I'm going to write the inequality. So on your paper, you would write your inequality. You're not going to do this one. You're going to do 1, 2, or 3. So I got that, and that's less than 195. So first off, the 212, that is boiling point at not at elevation, at sea level, right? That minus means the boiling point is lowering. This 1/500th means every foot is 1/500th of a degree lower. And E stands for the elevation. Now, we're not done yet. We have that less than, and then we have 195. So if all of that is less than 195, what is this? What is this trying to even say? So we might not even know what the rest is trying to say until we come up with a question. So we might have to come back. But question 2 says, write a question that can be answered by this. Essentially what it's saying is, if the question is asking for E, it's saying, what is, and by the way, you don't have to write all this. This is just a model for you to look at. It says, what is the elevation? It's asking for E. What's the elevation? And it's talking about water boiling points when the water boils at a temperature, and apparently this is saying less than 195. If the water is boiling at 195 degrees, at sea level it boils at 212. If it's boiling at 195 degrees or less, what's the elevation? So, next step is to solve this, right? And I might barely have enough room to solve this down here for you. So now I'm going to write 212 minus 100 E is less than 195. So there's my question. I now can go back and say that this is, this is a boiling point at elevation. And you don't have to write that. If you can't read that, I don't blame you, because I can't even. I just wrote gibberish. So that's the boiling point at elevation, right? And maybe I could say, maybe I'm going to circle that and draw an arrow. That's the boiling point at less than 195. So now let's solve this, because that is, I've done this. Check, write a question, check, show how you solve this. So step 1 is, I have this random number out here. I'm going to get rid of 212 from the equal sign. 212 minus 212, done. 195 minus 212 is a negative. What is it? 195, that would take 5 to get to 200, plus another, that'd be negative 17. Let's just do this old-fashioned way. I got to do 212 minus 195. Take the bigger one minus another, and I know it's going to be negative. I'm going to have to borrow 2 minus 5, 12. That's 7. 17. Negative 17. And that's going to be that. And I have a negative 1/500 E. Now, let me make that a little clearer. So negative 1/500 E is less than a negative 17. Now, to solve this, I need to divide each side by 1/500. Divide this side by 1/500. And it's actually a negative. Dividing by negative, if you remember, means I'm going to have to switch the inequality sign. But I'm also going to say, if I divide something by 1/500, dividing something by 1/500 means I keep this, I change this to times, and I flip 1/500th. 1/500 flipped is the same as, so dividing something by 1/500 is the same as timesing it by 500. If I were to times this side by 500, or negative 500, 500 times 1/500 is 500 500ths, which is 1, which is why all of that ends up canceling. So timesing a negative 17, I now have E on this side. I have to flip that around because I've divided by a negative. It's now going to flip. And now I have to do 17 times 500. Well, that's the same as 17 times 5 with 2 zeros. 17 times 5 is the same as 7 times 5 plus 10 times 5. That's 50 plus 35. That would be 85 with 2 zeros. And a negative divided by a negative is positive. So guess what? This makes sense. That's step. Show how you solved it and explain what the solution means in terms of the situation. Now I got to say the elevation is more than 8,500 feet when water boils at a temp less than 195 degrees. This is where that 195. So that was that problem. That was number 4. You can choose 1, 2, or 3. Number 1, if you're wondering, what kind of question could I ask? It's kind of saying, if I have 25 pounds of fertilizer, how many newly planted trees can I plant? It's kind of saying, if you look at that equation, it's saying how many, that X, remember, is the number of newly planted trees. It's kind of saying, well, how many new trees can I plant? If I plant a big one that needs 5 pounds, well, how many new ones can I plant if I have 25 pounds or less? So technically I could plant whatever your answer is. If you got 5 for your answer, which that's not correct, well, yes, I could plant 5, or I could plant 4. It's not like I have to use up all the fertilizer, or 3. It's just saying how many newly planted trees. So I'm going to kind of give you guys the questions there. Number 2 is kind of saying, let's see what it is. 1/7 of that amount? And 9 more of the chemical sucks. There can't be more than, it's kind of saying, to make each mixture, the students start with some amount of water and then add 1/7 of that amount of the chemical. It's kind of saying, my guess is, if I have 26.25, I would say grams of water or something, then how much of the chemical can I add? And then the last, number 3 is probably, seems like the easier one to me. It's pretty much kind of saying, well, if I start at 12 feet and I descend at a rate of 3 feet per minute, and I end up 37 feet below sea level, Is that the way we could say that? Or 3 feet per minute. So the X stands for minutes. I guess it's kind of saying is how many minutes would it take me to descend 37 feet? Maybe that's that kind of question. If I start at 12 and I ascend 3, if that's all that's going to be greater than or equal to the negative 37. That's kind of suggesting that, okay, I've ended up 37 feet below sea level. I guess maybe it's saying how long would it take me to get there. I'll let you guys analyze that a little more. I'm kind of glad that I'm not pinpointing it perfectly because I want you to do some thinking about this. So when you have decided on which one you want, do those 4 steps on a separate sheet of paper that your sub will give you if you don't already have it. And then when you are done, you can do lesson 16 practice problems. Now, let's see here. I forget. I'm kind of running out of time. I don't want it. That was 24. Probably running out of time. I will walk you through 1 or 2 of these, and then you can finish the rest. This is kind of interesting because we haven't really talked about an unbalanced hanger, but you can clearly see that 3 triangles would be greater than the 2 red circles. But let's go back up to here. Priya wants to look at the equality. 12 minus x is greater than 5. She says, I subtract a number from 12 and want a result that is bigger than 5. That means that the solution should be values of x that are smaller than something. Do you agree with Priya? Explain your reasoning and include solutions to the inequality in your explanation. Well, let's solve it. If that says 12 minus x is greater than 5, first thing is take off 12 from each side. And now I have a negative x is greater than, I told you they start to look like 7s. Negative x is greater than negative 7. That means a positive x, I have to switch it when I'm dividing each side by a negative, is less than 7. So look at what Priya said and see if that makes sense. Number 2, when a store had sold 2/5 of the shirts that were on display, they brought out another 30 from the stockroom. The store likes to keep at least 150 shirts on display. The manager wrote the inequality 3/5 x plus 30 is greater than 150 to describe the situation. When a store had sold 2/5 of the shirts, that means 3/5 of them were left, right? 3/5 of whatever was there plus the 30. What does a 3/5 in the equality mean? It means 3/5 is what is left. Not sold, right? They sold 2/5. 3/5 is what is not sold. 3/5 in the equality. Solve the inequality. All right. Well, I got 3/5 x plus 30 is greater than or equal to 150. Step 1 is subtract 30 from each side. Let's get rid of the 30 that he brought out. They brought out another 30. So that means 3/5 of what was left is going to be greater than or equal to 120. Now I got to divide each side by 3/5. Divide this side by 3/5. 3/5 divided by 3/5 is 1. 1x is what I want. Now I got to do 120 divided by 3/5, which is the same as keep, change, flip. And I would get 600 over 3, which is equal to 200. And so x is greater than or equal to 200. So he had 200 or more shirts on display. That's essentially what it means. Explain what the solution means in this situation. He likes to keep at least 150 shirts on display. Well, in this case, he had, is that what X means? They brought out another 30. Oh, that means at the time there was, 200 or more shirts on display. When a store had 2/5 of the shirts that were on display. When a store had sold 2/5 of the shirts, there was roughly 200 or more. All right, I'm going to let you guys finish the rest because I realize the bell might be ringing soon. So keep up the good work. I'll see you guys. I'll give you all credit for doing all this on Monday. Don't forget there's other videos that can help you with some of these other problems if you're still confused. But for right now, let's call it a day. Peace.